Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. Now, in today's lecture, we will continue with mensuration. So, yesterday, that was the first part of mensuration. And now, the second part of mensuration. Now, first of all, let's look at the syllabus once again. Conversion is part and parcel, whether it's conversion of length, whether it's conversion of area, whether it's conversion of volume, whether it's conversion between masses, whether it's conversion between milliliters and meters, something like this. Then 2D mensuration, that is about area, perimeter, rectangle, and then we have this thing, rectangle, triangle, parallelogram, trapezium, and circles, arcs, and sector. So these two, both of them collectively, 5.2, 5.3, that is 2D mensuration. And then there is 3D mensuration, which is about surface area and volume of solids. It's about cuboid, prism, cylinder, sphere, pyramid, and cone. And it's about all these things, the curved surface area, the volume, and so on. And then a combination of these, that is called compound shapes or composite shapes. So some people use the terminology composite shapes. Some people use the terminology compound shapes. It's a combination of two or more 3D figures. So now let's talk about prism first. What is prism? Prism is a thing, is a 3D object in which the cross-sectional area is constant. Now, in this case, the cross-sectional area is a sector and it's going all the way down. So the cross-sectional area is the same. Therefore, it's a prism. It has a cross-sectional area. It has a height. Now, just to give you some idea, if I talk about this triangular prism, it's just showing the shapes inside. That means it's a triangle on the inside. The same triangle is colored yellow. The same triangle is colored blue, and so on. So this is the face that goes all the way down, just like the cake slice that you have seen. In this one, there are 5 faces. There is a side wall. So on the left-hand side, there is a wall. There is a floor. There is a slant surface, that is this, which is basically a rectangle. These are 3 surfaces. Then there is a front, and then there is a back. And total surface area is sum of areas of all the faces. What about the volume? That should be the cross-sectional area multiplied by length. A cylinder is a circular prism. We talked about cylinder yesterday. There were some people who might not be present yesterday. And for the larger masses, what I've done is that this particular video of yesterday, which is Mensuration Review 1, I have uploaded it on YouTube and shared the link with you. And today's video, Mensuration Review 2, I will also upload it and share the link with you. So circular prism, this is the circle, and it goes all the way down. That is why the volume is cross-sectional area into height. And then if it's a solid thing, so total surface area of a solid or closed prism, a closed cylinder, that's 2 pi r squared. That is including the top and the bottom, plus the curved surface area, which is 2 pi r h. Now, a very simple example. And today, in order to cover lots of things, I won't be giving you any questions to try. I'll keep on going myself. Naturally, when you will be looking at the video, you can always pause, stop, try out the question, and then proceed. So now it says the diagram shows a solid prism of length 20 centimeter. So that is 20 centimeter. The cross section is a trapezium. So that is the cross section. That means if I cut it like this, another trapezium will appear. That is what it means by cross section. Now, sometimes if it's lying down, we talk about the length. If it's standing up like this, maybe something like this, and then it was standing up. So instead of this 20 being labeled as the length, it would be labeled as the height. And all these measurements are given. Calculate the area of trapezium. So this is 2, this is 6. These two are the parallel sides right over here. This 3 is the height. So area of this prism is half sum of parallel sides into height. That comes out to be 12. If they ask for the volume, which I have done myself because there is no part C over here. Yes, there is. I wrote it myself. So if I talk about this volume of prism, so that is related with the cross-sectional area, that is the volume, which is cross-sectional area into length. And then part B, the total surface area of the prism. The front is a trapezium, the back is a trapezium. So that is front is trapezium 12 right over here, back is trapezium 12 right over here. What about this wall? This is 20. It's a rectangle multiplied by 3. So 20 into 3, that is 60. So the sliding wall, top rectangle, bottom rectangle, and the sloping rectangle. And there should be this thing also. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. And I think I missed out this thing. So let me write over here. That is A, D, and let me label some other, what you call vertices. So this is A, B, C, D, E, F, G, and H. So I'm talking about this thing at the back. That's this thing. That is A, D, F, H. So the left wall, which is ADFH, that is 3 times 20. The area is 3 times 20, which is 60. I might have missed it out. Yes, I think I missed it out. So that's one thing. Then there is the top rectangle. Now let me erase this thing again. So let me erase this thing on the inside. And then when we talk about the top rectangle, which rectangle are we talking about? We are talking about this thing. We are talking about this thing, and this thing. So that is right over here. So now this rectangle is 20 into 2. This rectangle is 20 into 2, which is 40. That's done. What else is there? Let me erase all these colors from here. Is there a bottom rectangle? Yes, there is a bottom rectangle. That is the floor. That is this thing over here. So you just have to point it out. It's just something very easy. This is 20, this is 6. So 20 into 6, that is 120. That's also done. Now, let me erase this thing. Now, what is left? What about this face? Yes, this one. This rectangle over here, this one. The sloping face. That is 5 is this one. This is 20. So 5 into 20, that is 100. 5 into 20, that is 100. And left wall, this left wall was missed out. Left wall, that is area is equals to 3 into 20, which is 60 centimeters square. So now all these things are added up. 60 and 40 is 100. 100 plus 100 is 200, 200 plus 100 is 300, 320, 320 plus 24. So let me just correct this. So that is 300 and how much? 320 plus 24, that is 344 centimeters square. So I think the video that I made last year, I might have made an error. So if there is a chance, I'll go ahead and correct it. So I missed out this thing. That's one thing. Oh, there it is. I forgot to check the answer. It's right over here. Now, prism. Now look at this thing. This is a wonderful question. And over here, again, let me focus on it. The cross section of a prism is a sector of a circle, radius 8, angle 40. Just let me check one thing. The recording is on, the voice is on, everything is all good, all clear. So now over here, the area of this cross section, since it's a sector, that is theta over 360, 40 over 360 into pi into r square. What is r? That is 8. The prism is 20 centimeter long. Calculate the total surface area. And let me add one thing. I think the volume, I have not done it over here, but I can. So volume would be cross-sectional area multiplied by this length. Okay, so now this area is done. The total surface area. Now this is tricky in the sense because The total surface area would be this curved area like this. That is part of the prism. So since this is arc length multiplied by length will give me the curved surface area. The curved surface area is 2 pi r h, but it has to be in relation to theta over 360. Got the idea? 2 pi r, that is equals to the arc length. H is the height. So since we are not taking the whole thing, we are just taking 40 out of 360. So let's see how I have done this. I have given you the same idea over here in the shape of a cake. So arc length is 40 over 360 into 2 pi r. That is this much. Curved surface area is this thing into 20. Let me write an alternative way over here. So that alternative way is this, that the curved surface area of this prism is theta over 360 degrees into 2 pi r h. That's the curved surface area of prism. That is 40 over 360 degrees into 2 pi. Let it remain as it is. R is 8. And how much is h? H is 20. So this is 20. Now just look at the working. I have already done this thing in pieces. 40 over 360 is there. This is 2 pi r. First, I'm finding the arc length, then multiplying with this. It's exactly the same thing. 40 over 360 is 1 over 9. 2 over 9 is there. 8 is there. 20 is there. You get the same thing as over here. So let me just do a bit of cancellation. So therefore, the zeros cancels out. And then what else is there? 4 ones are, 4 nines are. And then 2 into 8. That is 16. 16 into 20 is 320. That is 320 over 9 pi centimeter square. That is the curved surface area. So all good, all clear. What else is there? Then how many rectangles do you see? I see this rectangle. That is 8 by 20. Of course, that shape is also on the other side. Of course, I cannot see the other side. And then there is the top is the sector and the bottom is also a sector. 5 faces. Top is a sector, bottom is a sector. Common cross section. Walls are rectangle, left 8 into 20, right 8 into 20. And the curved surface area is this. So total surface area is 2 times area of sector, 2 times area of rectangle plus curved surface area. This adds up to this much. At this point, use a calculator and you get the answer as this, and correct to 3 significant figures is this. So now I hope this is all good, all clear. And let me just write this thing, that is this prism thing. So this is this mensuration part 2, that is the lecture. And we are talking about prism. We are talking about this cake slice question. Is this all good, all clear? Okay, I'll just wait a bit. Now, after I'm done, I'll send some images from yesterday's work and today's work, some analysis which I have done and all these things, so that I'll send. Okay, so now I think another question. This is also a nice one. Just have a good look at it. Let me just take the figure and first paste it over here so that you can have a look without being influenced. Just don't try it out, just have a look. So just have a look at this question. What are they asking? What things need to be evaluated and so on. I'm just pinpointing few things. Diagram 1 shows a vessel in the shape of a prism. The cross section is a sector of a circle, radius 8, AOB is 90. In other words, this is a quarter circle. So this face is a quarter circle. quarter circle can be thought of as a sector in which the angle is 90 degrees. Calculate the perimeter of sector OAB. So for perimeter, I need of the sector that is OB 8, OA 8, plus this arc length, whatever the formula is, theta over 360 into 2 pi r, or 1/4 of 2 pi r, it's the same thing. The vessel which stands on horizontal table contains 800 centimeter cube of water. Calculate the depth of water in the vessel. So they are asking for this depth. So for this depth, this is the corresponding height. The cross section is the same. So therefore, I'll write volume is 1/4 of pi r square, that is the quarter circle area, into h. So this volume is 800, this is 1/4, this is pi, r is 8 square into h, make h the subject, that is the depth of water. As simple as this. First think, let me write this thing. First think, then evaluate. So thinking is a must. And yes, there will be a workshop starting next Friday. I hope everyone has registered. And maybe this Saturday or Sunday, I'm thinking of calling some people not to teach something, but to see their working, where the difficulty they are facing. So I'll also put a voice note over there. So that's all about prism. Let me remove this. Now, the pyramid. So prism is all good. Now, let's talk about pyramid. So in pyramid, this is just to give you an idea what a pyramid is. It has a base. So let me focus on this. It has a base. The base could be rectangle. The base could be square. And then there are sloping edges. So this is just the dimension, some history facts. That is what the prism looks like. The face is a triangle. There are 4 such faces: front, back, right, left. There are 4 such faces. Maybe some trigonometry will be used. Pythagoras theorem will be used. They would be asking for areas, and that is surface areas and volume. Now look over here. Do not confuse the 2 heights. There is a slant height and there is a height. When we talk about height, that is the normal perpendicular height starting from this going all the way down. The base, that is one of the length in the base. That's not the full length, that's like a half length. And on the, now it's touching on the sloping edge, there is this slant height like this. So yes, we will be working with some right angle triangles. Another diagram, that's called the apex or the zenith. And again, this is the height. This is the base kind of thing. There is a length on the base, and this is the slant height. This is called the edge. Now, if it's a regular pyramid, the base has equal sides. If it's an irregular pyramid, unequal length because of the base. If they talk about surface area, that's base area plus 4 area of any one, 4 times area of any one face. So 4 times area of any one face. And over here, if they are talking about surface area, that is the base area plus sum of all the faces, because sum of all the faces will be different. And more of these pyramids. When we talk about volume, the formula is 1/3. Let me just highlight it a bit. When we talk about volume, it's 1/3, and then it's base area into height. So it's just like a prism, but since it has sloping faces, it's not just base area into height. It is 1/3 of that. So volume of prism, that's cross-sectional area into height. Volume of cone, 1/3 base area into height. So cone is like a pyramid. Why? Because 1/3 is there common. Base area is there. In a cone, it's a pi r square. It's a circle. Over here, it's whatever the base area is. Height is there, height is there. Perpendicular height, perpendicular height. Now, just a simple diagram to get you started. This thing is 4. This thing is 3. This thing is 5, the famous 3, 4, 5 triangle. And this whole thing was 6. This thing is 6. Half of this is 3. What is the surface area? That's the base area, which is 6 by 6, which is 36. And the area of the lateral surface, this thing is like this, and this thing is already drawn. So now this thing is 6. This thing is 5, half into base into height. So half into 6 into height into 4, that is 60. That's the total surface area. Volume of pyramid, 1/3 base area into height, 1/3 base area into height. That is this. Now, something related to trigonometry that is often overlooked. That is this thing. Let me draw some triangles and let me just remove some misconception that's in your mind. That is a right angle triangle that I've drawn. The first one. Let me draw different kind of triangles. Something like this. That is the second kind. Then this is the third kind. So I've drawn 3 types of triangle. First of all, this is a right angle triangle. So let me just mark it. Okay, this is the height. This is the base. Area is half base into height. Everyone agrees with that. No one gets confused on this. Over here, the height is not given. So let me draw this height like this. Now that's the height. That's the base. It is necessary that height should be perpendicular to base. This is necessary. So now height is perpendicular to base, area, it's half base into height. Of course, we can also use half AB sine C, but I'm focusing on this thing. Over here, let me just erase this thing. Okay. Over here. Okay. So over here, this is the base. And where is the height? The height is on the outside. It's not on the inside, it's on the outside. So let me just extend this thing. So over here, this height is on the outside. So still area is half base into height. All good, all clear? The formula is still the same. There were 3 different kind of triangles. This is a right angle triangle. Height was part of triangle. Over here, height is inside. It's not what you call a side of triangle. Height is outside. Height is outside. It's not a side of triangle. You get it? This is one of the side. 1, 2, 3. There are 3 sides. Height is part of triangle. Height is not a side of triangle. It's just a perpendicular that you have drawn. It's just a perpendicular that you have drawn. This one is an acute angle triangle. So this one is acute angle triangle. Acute angle triangle. This one is obtuse angle triangle. All good, all clear. So let me just write triangle over here. And let me also write triangle over here so that there is no confusion. Right angle triangle. So whether we are dealing with a right angle triangle, whether we are dealing with an acute angle triangle, whether we are dealing with an obtuse angle triangle, it is necessary that height and base are perpendicular. The formula is the same. The formula is the same. Area is half base into height. Area is half base into height. Area is half base into height. A lot of people, they are confused with this. Now, different kinds of pyramids are there. We don't have to go into that much of depth. And over here, let's look at this question. So now it says ABCDE is a pyramid. So A is at the top and BCDE is over here. It's a square of side 10 centimeter. The sloping faces are isosceles triangle. So this is like 13, this is like 13, this is 10. So therefore half of 10 is 5. You need to grab your right angle triangle. So these are the famous right angle triangles that we come across, the 3, 4, 5, the 6, 8, 10, the 5, 12, 13. So this is 5. This is the perpendicular, that is L, and this is 13. So L comes out to be 12. Calculate the area of the sloping face ABC. So the area of the sloping face ABC, take this whole thing as the base, which is 10. Take whole thing as the height, that is 12. 10 into 12 into half, that comes out to be 60. So now in pyramid, we talked about the surface area, the lateral surface area, and then we talked about base area. We talked about volume. We talked about this concept of triangles, triangles, and areas, the concept of height and base being perpendicular to one another, and perpendicular. This thing, that is a must. So I think for a second, and I hope that this thing is all good, all clear. Then it says locus is not anymore part of the syllabus. A lot of people, they ask about congruency. Congruency is not part of the syllabus. Just the basic idea what congruency means, we will look at the geometry thing. Congruency means exactly the same thing. So now let's look at this paper 2 question. What does it say? It says in the triangle WXY, our WX is 24 centimeter. So WX is 24, WY is 17, angle is given. Calculate the area of triangle, that's half AB sine C, half AB sine C. Calculate XY, that is the application of cosine rule. So that's the application of cosine rule. I think that is pretty obvious. Now, how is it related to mensuration? That's how it is. The volume of pyramid is given. The triangle WXY shown in the diagram 1 forms the horizontal base of the triangular pyramid. So WXY, this thing, the same color, the red, the blue, the green, the red, the blue, the green, that is the base. And there is a point at the top, that is V. And this is a pyramid with a triangular base, a triangular pyramid. The vertex V is vertically above Z, a point on WX. So Z is over here and it's vertically above this thing. WV is 15. This is 15. WZ is 1/4 of WX. WZ is 1/4 of WX. Do we have WX? I think we had it. WX is 24. 1/4 of 24 is 6. So therefore, this thing is 6 right over here. So WZ, this thing is 6. So we have 15, we have 6, and we can find what is this thing, which is VZ. So 15 squared, 6 squared, VZ squared, VZ comes out to be √189. Now it says calculate VZ. The diagram is right over here. Find the volume of the pyramid. So volume of the pyramid is the base area, 1/3 base area into height. Height is what? Height is VZ. So 1/3 base area from the previous part, I think. No. Base area is, I think we calculated it over here. Yes, there it is. That's the base area. Use the unrounded value. And the height is VZ. Use the unrounded value. Plug this thing in the calculator. Use the unrounded value, 4 SF. And then this answer is there. Then you round it off. You get 3 significant figures. So I think pyramid is also done. Now let's start with composite shapes. So composite shapes, let's start with this. Now, Remember this thing, that when we talk about mensuration, there are other videos also in which every single PDF that I have shown over here, that is explained thoroughly over there. So if you have any difficulty with the basics, do take care of those things. So now composite one, which kind of questions are there? Now this is a important thing. What is a face? A flat 2D shape surrounded by edges and vertices. So that's an edge. All these are edges and these are vertices. So that is a face that you see. Edge, a straight line when two faces meet. So this face is meeting with this face. So this blue line is the edge. Vertex, a point where two or more edges meet. So 1, 2, 3, 3 edges are meeting at this point. That's a vertex, like a corner. Sphere, cylinder, cone, cube, triangular prism. Ignore this. Square base pyramid. The formulas are over here. I'll also share these things with you. And 3D figures. This is a prism. Whatever this shape is, that's going all the way down. This is cross-sectional area going all the way like this. Just studied prism, studied cone last time. Sphere, hemisphere. Now, when we talk about compound shape, I think I should give you one question to try. This is a paper one question. I think you can manage it. So let me just give you this question. And sometimes we need to do some questions from the past also. So this is 2015, not that far away. So let me just reduce it. You can see it on the screen. Let me pause the recording and just try it out for 5 minutes. So now people, let's look at this question. The question says, the volume of a cone is this, the volume of a sphere is this, the solid is formed from a hemisphere of radius r fixed to a cone of radius r, height h. Now, basically, this is a cone. That's the 3D shape, and it's fixed to this hemisphere. Now, the thing that you need to understand is this thing. In the hemisphere, we have the curved surface area, that is for sure. In the cone, let me highlight this. This cone over here, that goes like this. And then it's right over here. So let me just go all the way like this. And this is the curved surface area that we are talking about. So what is missing? Since it is attached, this is glued together. So if it's glued together, that means the base of cone, it's gone. And the top of hemisphere is gone. Got the idea? So now it says, find h in terms of r. What do we have? It says the volume of the hemisphere is 1/3 the volume of cone. So let me show you the working. Volume of hemisphere is 1/3 volume of the solid. That solid is volume of hemisphere plus volume of cone. Got the idea? Now, what I did is that instead of first putting in the formula, I first cross multiplied. I worked in terms of VH and VC. And this is the relationship. 2 times volume of hemisphere is volume of cylinder. Got the idea? So now this relationship that I worked out. So this relationship that I worked out, that is kind of tricky for some people. I have written volume of hemisphere is 1/3 volume of solid. What is the solid made up of? The volume of hemisphere plus volume of cone. I multiplied instead of opening with a fraction. 3VH is VH plus VC. 3 minus 1, that is 2VH. That is equals to VC. Now VH is what? That is 1/2, not half that of a sphere. And this is 1/3 pi r square h. And then you simplify what relationship you get. 4r is equals to h. So this thing, 4 times radius is equals to height. Is this all good, all clear? Now, if someone is not interested in this, let me also show you another piece of working. So what I can do is that I can write volume of, first let me write volume of hemisphere. That is half 4/3 pi r square h. Sorry, that is pi r cube. That is 2/3 pi r cube. Volume of cylinder, that is pi r square h. Volume of solid, that is volume of hemisphere plus volume of cylinder. People can also work this out. That's your choice how you want to work it out. That is 2/3 pi r cube plus volume of cylinder is pi r square h. Now, if I look at the statement, what does it say? Volume of hemisphere is 1/3 volume of solid. Can I write it like this way? Volume of solid is 3 times volume of hemisphere. So volume of solid is 2/3 pi r cube plus pi r square h is 3 times volume of hemisphere. Volume of hemisphere is 2/3 pi r cube. All good, all clear? So now, first of all, if I take this pi common out, naturally it would cancel out. So let me get rid of all these pi's. Now, what am I left with? I'm left with 2/3 r cube. I'm left with r square h. I'm left with 3 and 3 cancels out. That is 2r cube. Therefore, r square h is 2r cube minus 2/3 r cube. 2 minus 2/3, 2 minus 2/3, that is 6/3 minus 2/3, which is 4/3. So r square h is 4/3 r cube. Now, what can I cancel? I can say that h is 4/3 r cube over r square. So therefore, h is 4/3 r. Did I miss out anything? That is 2/3. This is 3 times volume of hemisphere, 3 times this. This is 2/3. That is volume of solid pi r square h. Okay. And I think I missed out something. That is a cone. That is, I missed the 1/3 from the cone. So this cone was 1/3. I forgot that. This is 1/3. This cone is 1/3. This cone is 1/3. This cone is 3. This is a 3. This is a 3. The 3 cancels out. And therefore, you get this thing. And h is equals to 4r. Now it's your choice. You want this working or you want this working? I personally prefer this working. So method 1, the color 1, color and VC and all this thing working, color versus method 2 that is working right now. So which one is better? This is the star and the color one is the, what you call the tick mark. Which one is better? Let me know. And then we'll move to the next part. This what you see, that is the color working. That is the tick mark. The other one is the star. So you learn with experience. You learn with experience, which is more concise. Okay, people. So now let me move ahead. And now it says the slant height of the cone can be written as r root k. So this slant height is right over here. I have denoted as L. So we have h, we have r, we have L. How are they related? L square, it's h square plus r square. What is h? 4r. When you square it, 4 will also be squared. So that is 16r squared plus r squared. That is 17r squared. Take square root of both sides. Therefore, L is 17 r root 17. Because r square, you can write down the square root as r. But root 17, you have to write it as it is. That is what they are saying. R root 17 is r root k. K is an integer. What's the value of k? That is 17. And then find an expression in terms of r and pi for the total surface area of the solid. So in terms of r and pi. So first of all, total surface area is the curved surface area of the cone plus curved surface area of the cylinder. What did I just wrote? There is no base of the cone. There is no top of this hemisphere because it's glued together. So therefore, the pi r L, that is curved surface area of the cone, we know L as r root 70. And curved surface area of a hemisphere, that's half the surface area of a hemisphere, that's 2 pi r squared. And that is as simplified as it can be. Remember this thing, you have a paint brush like I have, and just keep on painting. And as soon as you have that feeling, you know exactly what the surface area is. So now this thing is done. This looks like a nice question. This is a paper 2 question. Let me look at the parts. This is part 1, 2, 3. This is the same thing, right? Or is it different? No, I think it's different. Fill the pan, soup which is left. Yeah, it's the same thing. So let me just share this thing with you. Sending, okay, some issue. Copy. Add a page over here and sending it over to you. It's a paper 2 question. Let me pause the recording so you can try it out. So now let's look at this question. The question says a hemispherical bowl. First, let me underline it, then I'll show you the solution. It's a hemispherical pan contain 13 liters of soup. As many bowls as possible are completely filled with soup from the pan. Calculate the number of bowls which are filled. I think it's related to, okay. It's related to this part. My bad. I forgot to send you people this thing. So let me just copy this and let me add a page. First, let me read from this. So now the first part was this. It says the value of pi is 3.142, correct to 3 decimal places or 4 significant figures. 1 liter is 1000 centimeter cube. Some identical bowls are open cylinders, each of radius 6 centimeter, height 4. Each bowl is made from thin metal. That means ignore the thickness. Calculate the area of metal needed to make each bowl. Give your answer correct to the nearest square centimeter. Now, let me just write in terms of symbols, and then we can plug in the values later. So it's an open cylinder. That means there is only curved surface area, and then there is the base area. So the curved surface area is 2 pi RH. The base area is pi r square. Therefore, the total surface area is pi r square plus 2 pi RH. What is the value of r? That is 6. What is the value of h? That is 4. Now look at my working. First of all, I'll write pi into r square. That is 6 square. This is 2 pi r is 6 and h is 4. So this is 36 pi. 6 fours are 24, 24 plus 24 into 2, that is 48 pi. So 36 plus 48, that is 34 plus 50, which is 84 pi. And then at this point, I'll write the value 3.142. And at this point, I'll use the calculator. So this is the knowledge that I want you to impart in order to get the best possible grade. That is the first thing. So that is the first thing. Over here, I have even done this thing. I have taken common out. And then 84 pi, and then plugged in the value, get this answer rounded off to the nearest integer, because that is they are asking nearest square centimeter. Square centimeter is the unit. So basically they're asking to the nearest integer. All good, all clear? The next one. A hemispherical bowl contains 13 liters of soup. That is 13 into 1000 centimeter cube of soup. This is a pan. That is a hemisphere. And this is a bowl, that is a cylinder. Now, what is it saying? It's saying calculate the number of bowls which are filled. So first of all, let me write the information for the bowl. So bowl, this is R is 6, H is 4, and this is a cylinder. And let me talk about a pan. This R is how much? No, it's not given as R. It has only given us the volume. That is 13,000 centimeter cube. So over here, I need the volume of the bowl. That is pi r square h. That's pi into 6 square into h, 36 into 4, 144 pi. Therefore, this is what you are filling out. So volume of pan, let me change the color. So volume of pan divided by volume of bowl, that will give me the number of fillings that can be done. So 13,000 divided by 144 pi, the integer value, there would be some decimals also. The integer value, that would be the complete number of bowls which are filled. Calculate the volume of soup which is left in the pan. Give your answer in cubic centimeter. So up till here, let me show you the working. First thing, for the bowl, radius is 6, height is 4, volume of cylinder is 144 pi, volume of hemisphere is 13,000. You divide, you get 28.7326. That means 28 bowls will be filled and this much is left. Now, volume of soup from the bowl, that is 28 into 144 pi, that is this much. Left over is this much, that is 331 centimeter cube, that is left over. So now just acknowledge it over here. Where is it? So this is the pan, very classic question. And there are a lot of questions like this. So pan, bowl, filling, this question up till here, is it all good, all clear? And then I'll move to the last part. Last part of this question. It says the volume of a sphere of radius r is this much. Given that 13 liters of soup completely fill the pan, calculate the radius of the hemisphere. Give your answer correct to the nearest millimeter. So volume of hemisphere is half volume of sphere. That's the formula for volume of sphere. That is 2/3 pi r cube. This is 13,000. This is 2/3 pi r cube. Make r the subject. That is in centimeters. Convert it into millimeters multiplied by 10. Nearest unit, round it up, 184 millimeters. That's how you get this answer. Okay, so now let me remove this composite thing. Let me now go to this thing. And these are recent past paper questions. Let me choose something which is different. This is different, but I think I'll save it for the workshop. Now, something about the net concept. It says the diagram shows the net of a solid diagram of 1 centimeter grid. That means this is the top. This is the bottom. This rectangle will be wrapped around. This is the curved surface area. Which shape is that? This is a cylinder. Name of the solid, cylinder. What's the dimension? It's on 1 centimeter grid. So if it's on 1 centimeter grid, let me just add this thing. The diameter over here, the diameter is how much? That is 3 centimeter. Therefore, radius is how much? 1.5 centimeter. What about the height? That is this thing. That is the height. So the height is this much. That is 1, 2, 3, 4, 5, 6. So the height is 6 units. So the height is 6 units, and that is the dimension. Let's double check. I think I don't have the answer over here. It is somewhere else. Something. Try out this question. What you see on the screen, that is for 2 and this thing. And which year is this? This is May, June 2023, variant 22. So let me also write over here. This is May, June 2023, variant 22. And I don't remember the name. I think this is 8B. This is 8B. That is this question. So just look at this. Try it out. Let me pause the recording. So now people, let's try out this question, which is from May, June 2023, variant 2022. So let me write it over here. That is May, June 2023, variant 22. It's right over here. And this is question number 8B. What does it say? It says a piece of card is a sector of a circle with sector angle 75 degrees and radius 8 centimeter. 75 degrees, 8 centimeter. Find an expression in terms of pi for the arc length of the sector. Give your answer in its simplest form. That means reduce the things where possible, whenever, wherever possible. 75 over 360, 2 pi r. Pi remains intact. Simplify. This comes out to be 10 pi over 3. The unit is already written. And then it says volume of the cone. The formula is given right over here. So for the volume of the cone, where is the cone? No, the volume of the cone is coming up later. Over here, that's the question. The piece of card forms the curved surface area of a cone. So now it's wrapped around and that forms the surface area of the cone. The cone is filled to the top with water. So basically, we just take a piece of paper, wrap it around, it forms a cone. It's a hollow cone. Calculate the volume of water in the cone. So now this 8 from there, let me write one thing, which is not written over here. So let me grab a pen. If we are talking about a sector and it's becoming a cone, what about the radius of the sector? That becomes the slant height of the cone. So this thing, when you wrap it around, it's a very good question. This 8 becomes the slant height of the cone. What else is there? The next thing that you observe is that the arc length of the sector will now become the circumference of base of cone. Got the idea? So when I am wrapping it around, so when I wrap this thing around, what happens? That becomes the circumference. So therefore, 2 pi r, r is for this cone, 2 pi r is this arc length. So therefore, r is 5 over 3. So this r is now found as 5 over 3. This 8 is there. Can I find the height? Yes, I can find using Pythagoras theorem. So h square plus r square is 8 square. H square is 8 square minus r square. This is 64. 5 over 3 squared is 25 over 3. At this point, use a calculator. H comes out to be 7.824, 4 significant figures. What are they asking? Volume of water. Volume of cone, 1/3 pi r square h, 1/3 3.142, 25 over 9 into this thing. That comes out to be 22.76. This comes out to be 22.83 significant figures. So I hope you like this particular question. Let me write it down. So therefore, this is May, June 2023, I think. And this is variant 22, question 8, part B. This is all good, all clear. So now just have a good look at it. And I hope the recording was on. Yes, the recording was on. So now, this is all good. Let's move ahead. So let me just go over here. And why don't you try this particular question out? Let me try to send you both the images, this one and this one. That's from this year paper. And there's also Azan. So you will try this out. I'll pause the recording and I'll be back after 7 minutes or something. So I have this thing. Let me just pause the recording and try this out. So now people, this particular question is of November 2023, variant 21. So November 2023, let me go to this one. And variant 21, okay. And I'll also go to the mark scheme. Sorry, the examiner report. I think I forgot about it. There it is. Now, first of all, let's focus on this. It says the diagram shows a triangular prism. That is a triangular prism. AB is 6, AB is 6, angle BAC is 55 degrees, length of the prism is 20, area of triangle is 34.4, which triangle? ABC. So ABC, that means I can find this length. Calculate the volume of the prism, that is 34.4 into 20. That is very easy. Show that AC is 14.0. Show that AC is 14.0. So half AB sine C, half AB sine C, that is equals to 34.4. Therefore, you find the value of AC. For further calculation, use unrounded value. For this part, just use this particular value. So let me just highlight this thing. This is 3SF. That is the answer for this particular part. But for later thing, we have to use this particular value. Calculate the surface area of the prism. So this is one of the basic questions that we tried earlier. This is 6 into this length, that is 20, that is one wall. This length, that is 20 into BC, that is another one. The front is the triangle 34.4, the back is a triangle 34.4, and the base is this thing, that is 20 into AC. So look at this. Wall 1, surface area AB into 20, wall 2, AC into 20, wall 3, BC into 20. So we found BC using cosine rule, I think. And that working is not shown over here. And over here, 2 times the triangle, the front and the back. And this is what you are getting. The examiner has given both the answers. Any which way, they both simplify to 702. This is question 9, by the way. Now, this part, the diagram shows the cuboid with a square base. That is a cuboid with a square base. The height of the cuboid is 8. That's right over here. The volume of the cuboid is 98. So volume is this length into this length. It's a square base. That's why these two lengths are equal into 8. So therefore, x comes out to be 3.5. Then it says calculate PQ. So how can you find PQ? In order to find PQ, you first need to find the green length. So 3.5, 3.5, Pythagoras theorem, we get D is 24.5. I left the answer as it is. And then now this is the base, this is the height, and this is the hypotenuse. So there were 2 right angle triangles that you were dealing with. Got the idea? So therefore, root 24.5, 8 Pythagoras, again find this thing, PQ. So therefore, PQ comes out to be 9.41, correct to 3 significant figures. So that was a nice question. Let me first read the exam report for this one. Question number 9, what does it say? The exam report is missing for this one. So let me ignore this and let me go up. And I think which question was that? That was, I think, about, let me just find out. Common thing, ratio. 3 bars, have the candidates correct length and width. I think that was question 8. Yes, that was question 8. Let me just double check. So the previous question, that was question 8, May, June 2023, variant 22. So May, June 2023, variant 22. There it is. So let me highlight. This is May, June 2023, variant 22, question number 8. What does it say? Over half the candidates were able to calculate the correct length and width. However, some transposed their answers. They mixed up their answers. Some expressed the length and width correctly using algebra, but others didn't succeed in formulating the correct expression for the perimeter. As a result, leading to incorrect length. Common wrong methods led to a length of 13.6, width of this, length of this. Some candidates gave the algebraic expression for length and width. So basically, that was this part, which we skipped. And let's start with part B. Let me focus on part B first. So there it is. So now let me focus on this part, part B. It says around half the candidates were able to find a correct expression for the arc length of the sector in terms of pi. The 2 common errors were either to work out the area of the sector or to evaluate the arc length. So we have to find an expression. That is the first thing. This question proved difficult for many candidates. It was common to see attempts at using the arc length as the diameter of the cone or using trigonometry to find the radius with an angle of 37.5. These are mistakes that they're talking about. Others did not use the information already given about the piece of card, but instead assumed the radius was half of the slant height. They just assumed. So these are all mistakes. Having obtained a radius, many were able to use Pythagoras theorem to calculate the height of the cone, and then use both the radius and the height correctly in the formula for the volume of the cone. It was not uncommon to see attempts at the volume of the cone with either the radius or the height as 8. So these are all the mistakes that we are talking about. The way that we did it, that was the perfect way of solving that particular question. So I think that's a lot of review of mensuration. Go over both the lectures and wish you the best of luck. Go over the basic lectures if you find this particular lecture to be difficult, so that your concept is all revised and then you can ace your grade. Take care, everyone.